Hey class, let's do the lesson 7 homework. This is the first homework for second semester. Just graphing sinusoids, which maybe you're good at already, maybe not. Let's find out. Let's start with the first one, and let's start by pulling out all the relevant info. If you want the amplitude, remember, all you got to do is find the absolute value of A being this leading coefficient, let's call it. So absolute value of 2 is 2. To find the period, we had a formula. And the formula was that if we're working in radians at least, the period is going to be 2 pi divided by the b value. So the b value of 2, we're going to be going 2 pi divided by 2, which is going to give us a period of pi. The phase shift can only be found if you factor out the b. I shouldn't say can only, but like, it ain't this. We're thinking about an equation that's a times the sine of b plus c minus d, but this isn't c. It's not c until you factor out the 2. So let's rewrite the whole thing. It would be 2 times the sine of, factoring out the 2 essentially means you're dividing by 2. But rather than imagining dividing a fraction by 2, let's just imagine multiplying by 1/2. And you can see pretty clearly that this is going to become pi over 4. And then the minus 1 on the end. So that means our phase shift, well, it's not pi over 4 either. It's minus pi over 4. Because our general rule has a negative sign built in here. It's a times the sine of b times x minus c plus d. Which means here I must have a phase shift of negative pi over 4, which if you want to remind yourself, means we're going left. Then of course the minus 1 on the end, that minus does mean we're going down. There was no negative built into our sign, so if I see a minus here, then my value really is negative. So the vertical shift is -1, means I'm going down. It's also the d value. So yeah, d for down in this case. All right, let's find our values in, I don't know, gray. So the midline is the vertical shift. Our midline of our parent function would normally be 0. So if we're being dragged down 1 unit, then our midline will be at y equals 1. From there we go up and down according to our amplitude. That's the literal definition of amplitude, is it's the distance from the midline up to the max or down to the min. So adding 2 to 1 gives me a max at y equals 3. Subtracting 2 from 1 gives me a min at y equals -1. Then for increment on the x-axis, that's also called the step. It's the horizontal distance we change by between all the critical points. So if we're graphing a sine function, you should know that we want to start on the midline, up to a max, down to the midline, down to the min, up to the midline. And this is basically the pattern of points for our sine function, which actually means we could take this little drawing, put it right here in the pattern of points category. We want to start on the midline up to a max, the min, the mid, I'm saying this wrong, mid, max, mid, min, mid? It's like a tongue twister almost. Anyway, you should be able to see from there that those 5 critical points are dividing the period into 4 equal intervals. And that's our step. That'll always be our step. It's just going to be the period divided by 4. So it's pi over 4. I feel like this pen could be skinnier too. I don't know what's going on here. Oh, yes I do. We're at 150. I didn't ask for that, did I? What if we went to 100? Things would be small. Alright, whatever. Okay. So the period divided by 4 is pi over 4. That's going to be our step. Alright, a couple more questions here. What is the parent function starting point? For this little table, and I don't think we asked this on the quiz, but the parent function starting point for sine we can see would be the origin. What we can do now is apply all of these transformations to the origin and see where our new starting point would be. starting first with, I guess, the horizontal stuff that affects x. We would be just phase shifted. That's all we would worry about. I think so. I think that's all we need to sweat. So if we're phase shifted left by pi over 4, then the x-coordinate of our transform starting point will be negative pi over 4. Then in the y direction, handful of things happen. You might get reflected. If a is negative, you might get reflected. Then you would want to do your amplitude first. So you'd stretch your points up and down first. Then you would vertically shift them. So for sine, it's kind of a moot point, because if sine gets reflected, you're on the origin already, so you don't move. If sine gets vertically stretched, well, still, your value is 0, so that still doesn't move. So actually the only thing that moves the starting point of a sine function is this vertical shift. So we can see we would go down 1. And so our function is going to start here. And finally, I still just refuse to talk about this whole equation in terms of cosine thing. I simply do not care. So get wrecked. Okay. So instead, why don't we do some graphing? Now on the quiz, you guys aren't going to get the graph that I gave you on the paper. You guys on your paper had axes and stuff like that. I'm not doing that. I'm going to instead ask you to come up with your own. That's wrong. Come up with your own x scale. I'm going to ask you to come up with your own y scale. And then I'm going to have you place the axes yourself. So if you're all fastidious about that kind of thing, then bring your own straight edge. There we go. Okay. So for the x scale, we said that you want to make sure you pick a number that cleanly divides your horizontal measurements. And in the horizontal direction, we would want to make sure, our period matters, but really it's more the step that matters. And the step comes from the period. Those things are related. So let's just make sure we pick an x scale that plays nice with the step. But we've also got a phase shift that we need to play nice with. Now this problem, it's really a moot point. We can see that we would just pick a scale that goes by pi over 4. The one thing you might do though is, instead of having a step of pi over 4, that would be every single box, right? So you'd have like midline to max to min to midline, and that. If that feels a little bit crushed to you, that's a little small, then you could stretch out your scale so that every 2 boxes is pi over 4. Then you're counting by pi over 8s instead. So then you'd get midline, max. Our max would really supposed to be at 2, midline down to the min. That might feel better to you, just to have the graph stretched out a bit. So that's really your call at this point. You want to pick a scale that works. So I think I am going to do that. I'm going to go by pi over 8s instead of pi over 4s, which means I'm going to be moving 2 boxes at a time. Now 99 times out of 100, I would say it is totally fair to pick a y scale. That's just 1, because all you have to satisfy here are the vertical shift and the amplitude. Those are typically going to be pretty small numbers, and so going by 1 is going to be fine. But there'll be times when I give you an amplitude of like 1/2, and then maybe you got to go by halves or even go by a quarter to get the thing to fit onto the grid nicely. Maybe we'll see those in this homework assignment. I'm not sure if we do or don't. But we can cross that bridge when we come to it. I am just going to go by 1s. This wouldn't be an awful one to go by halves, but I'm going to go by 1s. I think it's fine. All right, now to place my axes. I don't have a ton to consider. Our vertical shift is just down 1. So if this line is the middle, then I guess I could shift up by 1 to account for that. But that doesn't seem super relevant. So I'll go here. Whatever, that'll be x. From there, I'm just going up and down by 2. So there's plenty of room vertically. Horizontally, same deal. We're phase shifting by pi over 4, which is just 2 little boxes. So there's plenty of room to shift 2 boxes left. and there's even plenty of room to be stepping by pi over 4, which is 2 boxes. So if I don't know, if I put my axis right smack dab in the middle, we'll be fine. I'm going to phase shift left 2, then I'm going to be stepping right 2, right 2, right 2, right 2, right 2, and then we see there's plenty of room to be dropping points in. So now I would say, one thing I like to do is go ahead and make horizontal lines, just representing my midlines, maxes, and mins. Horizontal line tools here. I'm going to just use this tool. I'm going to do it in, this blue. This blue seems great. So we're going to vertically shift down by 1, and that's going to put a midline right here. I hope that blue shows up decently. Then we're going to go up and down by our amplitude, which is 2. So that's going to put a max up here at positive 1. And that's thick. And a min down here at negative 3. So that's all plotted. Now I suppose I could mark my phase shift. My phase shift wanted me to go pi over 4 to the left. Again, based on my scale, pi over 4 would be 2 boxes left. So I could mark that. Now because I'm a sine function, I know I'm going to start on my midline, so I'll drop a point right there. Now we also, remember, we knew that point. We knew we wanted to be at negative pi over 4, comma 1. So we're left 2, down 1, there we are. From here, you now start stepping by whatever your step is, pi over 4. So we're going to go 2 boxes. Now because we're a positive sine function, you know that from this midline we are increasing. So in 2 boxes we are going to be up at our max. Then 2 boxes later we start to decrease again, so down to the midline. 2 boxes later down to the min. Now of course from the min the only place to go is back up. So you guys didn't have instructions about how much to graph, but I'll tell you the quiz is going to ask you to graph 2 full periods. So I just plotted 5 points, but I'm going to need 4 more. So I'm going to go 2 to the max, over 2, midline, over 2, min, over 2, midline. And now this is a grand total of 9 points, and that's showing 2 full periods. So the deal now is you have to connect the dots kind of cleanly. So remember, this thing should be concave down on both sides of the max. Now this guy should be concave up on both sides of the min. So basically, I would sketch these by kind of just imagining drawing little parabolas. These are, of course, not parabolas. Parabolas are a very specific shape, and these aren't them. But I think it would probably help you to just imagine that you're drawing little parabolas. And then you're going to get a good enough looking picture. But that's it. I think we're done. Wouldn't kill you to get in the habit of marking your starting point. So that's my starting point. Every once in a while you'll try to graph 2 periods and you'll run out of space. And when that happens, you'll have to come back to your starting point and kind of go backwards. In that case, you definitely better mark your starting point so that I know that you phase shifted correctly. Here it's obviously not as important because we can tell that we started where we started. Hope that made sense. Anyhow, I'm done with this. Again, I still just don't care about rewriting the function. I'm not going to do it. I refuse. Let's do 2. Okay, so a lot of the same stuff here, so I'm going to go through it quickly if I can. Shrink that a smidge, put it here. Plenty of room, I guess. Okay. So again, for the amplitude, we said amplitude cannot be negative. It's the absolute value of A. So our amplitude is 3, not negative 3. Our period is going to be pi divided by the B value. Well, 2 pi. Well, 2 pi divided by a half is 2 pi times 2, so it's 4 pi. May as well hop directly to the increment. It's going to be the period divided by 4. So you know our increment is going to be pi. We'll just put those in the same color since they're related to each other. I don't know. What's our phase shift? Well, again, we're not in factored form. Here would have to be factoring out the 1/2. Factoring out the 1/2 is the same as multiplying by 2. You'd be looking at 6 pi over 4, which reduces down to 3 pi over 2. So our phase shift is 3 pi over 2. And since this is plus, we know this is minus. Since this is minus, we know that we're talking about a movement left. Now our vertical shift is just the number on the end. That's going to always be probably the easiest thing. So +1, that means we're going up. So let's give these midline values. Our midline will always be that d value, so it's 1. We're going to go up and down by 3, so the max will be 4, the min will be -2. That's about it. I don't think I'm asking for any of this garbage below this line, on the quiz at least, so you can kind of tune this out if you want to. But the parent function starting point, we're a negative cosine function. Well, no, we're not. We're a cosine function. So a cosine function would start at the max and go like that. So we're going to give that coordinate 0, 1. That's the parent function. So the transform starting point, again, the only thing that would matter is that phase shift. That would give us our new x coordinate. It'll be -3π/2. Then we do have 3 transformations that affect us in the y direction. First would be this reflection. So our point at 0, 1 would be, let me write it down here. Starting from 0, 1, reflection happens. So we go to 0, -1. Amplitude happens. We get stretched by a factor of 3, so we go to 0, -3. Vertical shift happens, meaning we get pushed up 1, so we go to 0, -2. So that's what happens. So what happened from here to here? We reflected. What happened here to here? Vertical stretch happened. And what happened here to here? Vertical translation happened, giving us that final starting point. All right, what's our pattern of points? Well, it's not this because we got reflected. So our pattern of points will be min, mid, max, mid, min. Shoink. There you go. Again, I simply refuse to do this. Okay. All right, we got all of our ducks in a row. Do we have our ducks in a row? I would say that our ducks include these lines. So let's draw these lines. So axis first, apparently. We've got a vertical shift just up 1, so I guess if you spot the middle, maybe go down 1 from there, make a little extra room up top. Vertical axis can typically go square in the middle. Our phase shift is not a huge deal. No. I don't know. Maybe it is. Maybe I should make more room, because if we totally plan this through, looking at the phase shift in the increment, you're going to want to go by pi's over 2, which means your initial phase shift is 3 to the left. I have a feeling we're going to land here-ish, right? 3 to the left. But then our step is rather large. We're stepping by pi. No, that's not bad then. I was thinking we were going to go by pi's over 4, and this had us moving 4 boxes at a time. Let's just pretend that was the case. If I had to move 4 boxes at a time, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, I'm going to run out of space pretty quick. So if that happened, then I would maybe want to kick my axis way over, just to give myself plenty of room to push to the right. Although it's fine, you can always push to the left if you need to complete your 2 full cycles. So it's kind of a moot point, and I'm wrong anyway, so who cares? So yeah, x-axis goes there, it stays there. I'm going to continue my tradition of marking the midline min and max. So our midline is going to be at 1. We are just going to go by 1. So there's my midline. We said the max was going to be 3 units up from there. So here, rats. There's the max. 3 units down from there, 1, 2, 3 is here. So I got everything cordoned off now. Haven't chose the actual x scale yet, although I did informally. I talked about it, didn't write it down yet. I'm going to take all this, move it over here. That's behind my face. Put it up there. That'll do. So this will be an important part of the quiz, is actually giving me those scales. if you don't give me this, that's actually going to be a big problem. Don't make me assume. You got to actually write it. So like we said, with pi over 2 and with pi, we're going to pretty clearly just go by pi over 2's. That turns my initial phase shift into a 3-box movement to the left. It turns my step into 2 boxes between critical points. So easy peasy. For the y scale, we already did it. We're going by 1s. And it's, like I said, it's going to be 1s almost always. All right, so we've got our transformed starting point, but I don't really think that's worth it almost, because, I mean, you know our starting point is whatever our phase shift is, so you go 3 boxes left, mark it on the x-axis. Then you just ask yourself, what is my starting point? And it's a min, because we're a reflected cosine. So just go to where the min is, and you're done. So is that the right point? Sure it is, but I don't know that we needed to do all that calculating in the first place. Just, go through the process and you'll plot the point in the right place. I'm now going to step 2 at a time, and I'm going to follow my pattern of points. From this min, I'm going to go 2, then I'm going to be on the midline, then I'm going to go 2, I'm going to be on a max. And notice I don't have to think about much now because I've already incorporated the amplitude into my y values. I've turned my step just into 2 boxes, and that's taking care of the fact that I'm stepping by pi, which will take care of the fact that my period comes out to 4 pi. All that labor we did up front means that what we're doing now is relatively mindless and robotic. So we started in the right place. Now we go over 2, up 3, over 2, up 3, over 2, down 3, over 2, down 3. There's 1 period, but I said I wanted 2. So over 2, up 3, over 2, up 3, over 2, down 3, over 2, down 3. And you got the whole thing. So again, just connect your dots. Start by drawing sort of a half parabola. Then you got sort of the full one. So draw a nice concave down parabola, little concave up parabola, little concave down. Oh no. I don't love that break. I'm going to redo it because I got to model what I'm looking for. So smoothness. Smoothness. All right, that looks fine. We're done, by the way. That's it. You know what I think we probably overlooked was asking you guys for domain and range. But, kind of a dumb question, because kind of easy. I'll just ask it anyway. Zoop, move my face. So what's the domain if I did decide to ask you? Domain's all reals. The domain of sinusoids is always going to be all reals. There's no input that we are not allowed to enter. There's no restrictions. There's no asymptotes. So that's easy. What's the range? Well, the range is always going to be a closed interval that goes from whatever your min is to your max, inclusive. So that's pretty easy. We've already laid that out. We're down here at -2. We're up here at 4. So it's literally just -2 to 4. So the domain and range will always sort of take that form. The domain will be all reals, and the range will be stuck between 2 finite values, whatever the min and the max are. This will be more interesting when we get to the next 4 trig functions. When we get to secant, cosecant, tangent, and cotangent, suddenly we'll have more fun doing domain and range. For sinusoids, it's whatever. But that's 2. Let's do 3. I'm going to bring my face back down. Face go here. Zoop. I'm going to give this the old shrink-a-redo. And maybe I'll embiggen this a little bit. Alright, let's do it. I'm going to go just way faster this time. You know what? I might even do it without even talking. Let's just see what happens. Ready? Here we go. pulling out all that stuff should be easy. If you don't know how to do this, then go back to 1 and 2. I want to show you guys that this can be done a lot more quickly. So I'm going to keep my trap shut and just show you that no, this doesn't take 100 years to do. You should be able to get through it fast. Getting that wrong again. Alright, I think I'll talk you through this part. This part's a little more interesting. So here are the two numbers that we want to make sure our scale plays nicely with. We've got different denominators. That's going to make it a little hard to choose. But get a common denominator. It's going to be pi over 12s. This is 2 pi over 12s. This is 3 pi over 12s. Given that information, guess what your scale is going to want to be? It's going to want to be pi over 12. If you set up your x-axis to be counting by pi over 12s, then your initial phase shift will be 2 boxes, and then your step will be 3 boxes, and that's all you got to do to think that through. For the y scale, things are pretty tight here. An amplitude of only 1 means everything's crushed together pretty small. So this is going to be a time that I go by halves. I'm going to place my axis. I am going to want to bring it up a smidge. With all these values in the negative, you pretty clearly want your x-axis to be up a little bit higher to give yourself room down here in these quadrants. But your step, your increment, or your phase shift are all still relatively small, such that we can put the y-axis pretty much anywhere. I'm gonna push it a little bit left, I guess, but that's not really important. I am gonna stick to my plan of plopping my midline down. So if we're going by a half, that's going to be 4 boxes down. Here's 1, 2. So the midline go here. Then with an amplitude of 1, we're going to go up 2 boxes. Oh, that's supposed to be blue. That's supposed to be blue. They're blue. Alright, so now you can see we've got everything cordoned off vertically. Now, where's my horizontal shift? We said it was 2 boxes, right? Now with a minus here, it's 2 boxes actually to the right. I think the other ones have been to the left, but we're going 2 boxes right. So I'm just going to mark that there's a starting point right there. Then I'm just going to start plotting points. I know that with a negative sine function, my starting point is still the midline, so I'm going to be here. Now, the only difference is normal sine, non-reflected sine, would be increasing up to a max, but we are going to be decreasing down to a min. So again, what's our step? It's 3 boxes. So we're going to go 3 boxes at a time, and then we're down to a min. We're going to go 3 boxes back to the midline, 3 boxes up to a max, 3 boxes midline, 3 boxes min, 3 boxes, here I go. So this is it where I run out of points, because our first full period is here. That's terrible. Really try to, oh God. Try to be symmetrical, because I'm going to be mad. Okay, this is hard with a stupid stylus on a tablet. Alright, notice we're only getting half of a period here. So we better kick this way to get another half period. So we said it was 1, 2, 3. The preceding point would be a max. 1, 2, 3 would be on the midline. So I can add another chunk here. So now what I'm looking at is 2 full periods, but you know, stress that this guy here is really the starting point. And I've pushed out as far as I can right, and I had to squeeze a little bit more to the left just to get the 2 full cycles. But that's it. We're done. That's the one tiny twist, I guess, to number 3, is to make room, we had to go left. I think there's just one more, so we'll do it quickly. Alright, amplitude's 2. Period is 2 pi divided by 3. 2 pi divided by 3, if I divide it into 4, I'm multiplying by 1 over 4. So it's 2 pi over 12, which is pi over 6. That's our step. Our phase shift, we got to factor out that 3. I know I haven't been writing this, I just don't care, but I'll do it this time. 2 times the cosine of, factor out the 3. If you factor out the 3, then this pi will be pi over 3. plus 1. So we see that our phase shift is pi over 3. And it's to the right, again, because it was negative. Our vertical shift is 1 unit up. So that means our midline will be at the vertical shift, which is y equals 1. Then we're going up and down by 2. Y equals 3, y equals -1. I think we've seen exactly those values already. I honestly don't care about anything else. I don't even care about this max midline min thing. But yeah, I'll keep going. The parent function starting point for cosine would have been a max. It would have been 0, 1. If we apply our transformations, then we're going to the right by pi over 3, so it'll be positive pi over 3 as an x-coordinate. Then there's no reflection, so I don't have to reflect, but I do get stretched by a factor of 2, so this y value will go to 2. Then I get vertically shifted up by 1, so that y value goes to 3. So those will be the coordinates of our starting point. And our pattern of points is the same old, same old. We're going to start at that max and go like this. And again, no. 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 Okay, this thing. What would the x scale be? Ask yourself. Take a long look in the mirror and decide what you would say. I hope you decided, because I know I did. I've decided pi over 6? Pi over 6? Could be pi over 12. If we went by pi over 12, then our initial phase shift would be 4 boxes, and that's fine. We're only moving by 4 boxes the one time, and then our increment would be 2 boxes at a time, 2, 2, 2, and that's not too big. The way it is, if I go by pi over 6, which I'm sure I'm going to, then our initial phase shift is just 2 boxes, but our step is only 1 box at a time. That is going to give the feeling of our graph being pretty crushed in tight on itself, but that's fine. If you don't like that idea, then go by pi over 12. For the y scale, I think we could go by halves again if we wanted to, but I'm going to go by ones again. It's fine. So this graph is going to appear kind of small in our window, and that's fine. If you don't like that, change your scale. So again, if we're going up a bit, then I might cheat my axis down just a smidge. The phase shifts and the step are not anything too wild, so I think I can just put my axis in the middle. Now, I can plot my midline. We're just going by ones, right? Yeah. So the midline then will be here at 1, which we already knew. I forgot that we already said that. Our max will be 2 units above that, so that's going to be at 3. Our mins will be 2 units below this, so they'll be at -1. So there's that. Where's our phase shift? We said it's pi over 3 to the right. So pi over 3 is 2 boxes. So we go 1, 2, and right here is going to be where we start. And because we're a cosine function, we know where we're going to start. We're going to start at a max, so right here. So we can plot our first point. Then we can just start walking by pi over 6's, which is just 1 box at a time. So 1 box later would be on the midline. 1 box later would be at a min. 1 box later we're back on the midline. 1 box later and we're at a max. And I can easily fit 2 periods because our step is only the 1 box at a time. So I know I can just keep going. Bing, bong, boom, boom. So even though this is kind of tight, keep your graph looking good and symmetrical and curvy. That was good. Feel good about that one. If I can do that with this stupid stylus, then you guys can do it with an actual pencil. So alright, we're kind of done here. That's the whole homework in the bag. Zoop. Oh, that didn't work at all. Or did it? No, that didn't work. Alright, if you can't see this stuff at the bottom, I don't know if you need to. That's just the scale down there. So you're probably fine. Alright, 35-minute video. That's a short one for me. But we're done. Have a good one.